Hello everyone. In the previous session we have seen what is Avro file format, Parquet file format. Today we shall talk about how do we write and read from Parquet files and what is protocol buffers, what is Thrift, etc. So first let us talk about how do we read and write from the Parquet files, right. So most of the time whenever we are processing the Parquet files, they are processed at the higher level. What do you mean by processed at higher level tools? We generally use Pig, Impala, Hive, etc. These are the higher level tools, and sometimes we might go for sequential access also. Sequential access is always treated as a low level access, and the rest of the accesses which we are using tools like Pig, Impala, Hive and all, they are treated as higher level access tools. Now, Parquet has a pluggable in-memory data model to facilitate integration of Parquet file format with a wide range of tools and components. Do I need any additional code to be written if I want to use a higher level tools for accessing? Definitely not needed. It is easily pluggable. So, Parquet comes with the pluggable modules for accessing the data with these higher level tools. Now, whenever we are trying to work with Parquet file reading and writing, we have two types of implementations given in Java: read support, write support. They are the integration points in Java, and these classes are implemented to convert the objects which are used by a tool or a component, and we are trying to go for an object which is represented in Parquet. So these read support and write support, they are actually classes which are implemented in Java, which will help me to access an object which is written in any language, and you can map it to a Parquet object, vice versa. Right. So for example, consider a simple in-memory model which comes bundled with Parquet in parquet.example.data and parquet.example.data.simple packages. These are the two packages. I have tried to show the example. This I have taken from the textbook Hadoop Definitive Guide. You can very well refer to that. So just go through this example. We want to write a Parquet file. We need to define Parquet schema represented by an instance of parquet.schema.message type. Whenever we want to write into Parquet file, first we need to define the message schema. Every data that is being written into a Parquet, we call it as message type. So first I need to define the schema. Now say for example, I am still using the same example wherein we are trying to have a string pair, which we have seen while learning Avro. The same example we are using, I want to write a pair of strings. So how do I represent the schema? In Parquet there is nothing called as string data type. Everything which is represented as a string will be given the format called UTF-8, Unicode text format, 8 bits. So we are using the same representation. So how do I define the schema? If you see, message type schema is equal to message type parser dot parse message type. How many messages do we have? It's a pair separated by new line character. First one, it is required, binary. What is the name of the first string? Left, which is in UTF-8 format. Later, second one is called as right, which is of binary UTF-8 format, and this is also a required field. So I cannot leave either of them as empty whenever I am trying to send an object. Then after the schema is defined, we need to create an instance of a Parquet message for each record to be written into the file. So whenever I have defined the schema, say for example I want to write 5 string pairs into the file. For every instance of the record I need to have an object instance. So you might need to loop the set of statements which we are showing here, right. So for example, I have shown here to write a single variable or a single record, but if you want to do it for multiple objects, you need to put it in a loop, or If you don't like to work with loops, always you have an option of working with individual object variables. Now, group factory, this is the object. Whenever you are trying to work with defining an object, you should write it as group factory. What is the variable name we have given? The same variable name we have used with g as lowercase. You are trying to instantiate an object belonging to which schema? This schema which we have already defined. If you observe, the name of this message type is schema. So, we are trying to create a group factory with schema which is defined above. Then we are trying to instantiate a group factory. Then we are trying to append to that group. What is the first one? Second one we are trying to append. This is the actually header row. And later on, whenever you have the objects, you can keep on append them. We are using append, not simply write object. Append always leaves the original data, keeps on adding at the end. So, the values in the message are UTF-8 logical types. So, this is to be always kept in mind, because in Parquet we do not have any primitive data type for string. Everything will be shown as binary UTF-8. And a group provides natural conversion from a string for us. Now, whenever you are writing the code in Java, Java has a default string data type. We are trying to have a string of Java to be converted into a Parquet's UTF-8. Who is taking care of that? This group factory and this group, they will take care of automatic conversion of a string into Parquet's understandable UTF-8 format. Now, try to see this one. I have taken the same code from the textbook, which is trying to create a Parquet file and a message to be written into the file. So, just go through this code once. Defining a configuration object wherein the configuration is the place which takes care of mapping, associating the Java code with Parquet. All such configurational issues will be taken care by the configuration object. You are trying to define path for the file, and mind the file has an extension Parquet. If you remember, if it is Avro, you will have .avro. If it is a schema defined in Avro, you will have .avsc, stands for Avro schema, and if it is a Parquet file, it will be having an extension .parquet. And you are trying to take a group write support object. Group write support, set the schema. Whatever schema we have defined in the previous slide example, the same schema we are using, and it should be given with this configuration. You are just making the association. Then you are associating the writer object with the path. Under that, if you see, all these are the parameters. What are the parameters we have? What is the default compression codec we are using? So, you have to specify the compression algorithm if at all we are compressing the data. Otherwise, you can leave it. Block size, what is the block size? Page size, what is the default page size? You need to specify. If you observe, there are two page sizes. The first one is for actual data, second one is for the dictionary. Similarly, do we have dictionary enabled, or if it is not enabled, if dictionary is not enabled, this page size can be omitted. Similarly, is validating enabled? Can I leave some of the data empty? Remember, if you remember, schema is defined as both these strings are required. So, if the user is trying to enter the data and if he misses some of the data, should I do the validation or I should keep quiet? You are asking that also. Default is validating enabled or not. Similarly, Parquet properties, writer version dot Parquet 1.0 is the version we are trying to work. Once this is defined, writer dot write group. So, once the first object is written, we are trying to close. As I told, if you have multiple objects, maybe these are to be kept in loop. As many number of objects you have, those many times the loop has to repeat. So, if you see, it is given here. The write method would normally be called in a loop to write multiple messages to the file, but here in this example, it is writing only one message. As I told, this writing concept can be kept in loop for multiple objects. Now, writing is done. How do I read data which is there in Parquet file? Reading a Parquet file is very simple compared to writing option, since schema does not need to be specified and it is stored in a Parquet file. Whenever we are trying to store it in Parquet file, we need not define schema while reading. While writing, I need to specify the schema because whatever data I am trying to write into the file should confine to the schema. But when you are reading, you will read it into variables or you will read it into an object. So, you need not bother about what is the schema of the file specifically when you are going for reading. And how are we trying to read? If you see through these two lines, here we are working with read support and reader object. When you are working with write operation, you are using write support and writer. Here when you are working with reading, you take help of the objects read support and reader objects. And it has a read method to keep on reading the next messages, and it returns null when you are trying to reach end of the file. Just go through the code. How are we reading? This assert not null, always you do not want to do anything when you have encountered a null. So, you are asserting you are not reaching a null value. First string is read into left, second string is read into right, then you are trying to say reader dot read. And if you observe with left and right, we are giving a second parameter called 0. What for are we giving that? Note that the 0 parameter passed to the getString method specifies the index of the field to retrieve, since fields may have repeated values. See, for the same string pair, I might have given multiple strings. I want to take the first occurrence. I do not want to take multiple occurrence for the same object. I can give you an example. Say for example, you are trying to mention the first name and last name of people in a family, right? So, all the people belonging to the family, if we consider it as an object, the first and last names will be of multiple values, because in that particular family object I have multiple people. So, the first name and last name will have multiple occurrences. There are 5 people in the family 1 consider. So, family 1 is an object in which I will have 5 first names, 5 last names. So, in such case, if the object has multiple occurrences, you are always trying to take the first one. So, 0 specifies if multiple occurrences are there for that first name and last name, or first string and last string, try to take the first occurrence, right? And when you are trying to talk about Parquet Avro, you need to learn 2 more concepts which are very, very important: protocol buffers and thrift. So, what exactly are they? As part of your theoretical examinations also, we will get questions on protocol buffers and thrift. Write a short notes on protocol buffers, etc. So, let us quickly look at what are protocol buffers and thrift. So, first I will concentrate on protocol buffer, then I will talk about thrift. Most applications will prefer to define models using a framework like Avro, protocol buffers or thrift, and Parquet caters to all these things. Parquet will take care of working with all these frameworks. Instead of Parquet writer and Parquet reader, suppose I am using Avro file. So, I need to use Avro Parquet writer. If I am working with protocol buffers, I need to use Proto Parquet writer. If I am working with thrift, I need to use thrift Parquet writer, right? You are trying to work with Java and Parquet, I simply work with reader and writer. Instead, I am trying to stay in Avro, want to read a Parquet file. We will be using Avro Parquet writer and Avro Parquet reader likewise. These classes take care of translating between Avro, protocol buffers or thrift etc. Now what are protocol buffers? In short, protocol buffers is called as protobuf, which is short for protocol buffers, which is an efficient language agnostic data serialization mechanism. What do we mean by this? It helps me to serialize the data, right? Then it enables developers to define structured data in a .proto file, which is then used to generate source code that can write and read data from different data streams. Just try to understand this one. First, you are trying to define a structured data, just like a schema. The file extension will be .proto because you are working with protocol buffers. Then using this file, you can generate the source code. Let us see some more about protocol buffers. And protocol buffer uses a binary data format which is more compact and faster to read and write, and it always has the text based formats. It also provides an interface definition language that makes it easy to define the structure of the data to be serialized. Whatever may be the format of the data, it will try to give us an interface definition language with which I can try to work with the data as if I am working with text based information. And protocol buffer, as I told, it will be saved with the file extension .proto. This file contains all the information about the structure of the data. So most of the time you will be talking about the schema maintenance under protocol buffers. The data is modeled as messages, which are groups of name value pairs. Whenever you are working with protocol buffers in order to define the structure of the data, we call it as message, not as object, not as data type. We call them as messages, which are similar to dictionaries with key value pairs. And the .proto file can be compiled into several programming languages using Protoc, stands for, it is not actually Protoc, I should pronounce it as Proto-C, stands for protocol buffer compiler. So this protocol buffer compiler will try to compile the .proto file into various programming languages. And compilers, whenever we are working with Proto-C, it tries to generate source code in the programming language which you are specifying. And the source code includes classes, methods for working with the message object which is there in the proto file. So you can definitely generate a source code. I want to take a .proto file and generate code in Java. It will be a list of classes. It will see through the messages and defines a list of classes. What is the class structure, what are the data members, member functions, etc. The source code will be defined, and who is doing the job? The Proto-C, the protocol buffer compiler. And how the protocol buffer is different from other data formats? It is first schema based, and all the data is modeled as messages which are name value pairs, and data is strongly typed. It strictly follows the data types, and each data structure is defined along with the data type. And also compilation step is there, and it uses binary serialization format which is taking less space, so it is compact and efficient, and it also provides direct support for remote procedure calls. And other data formats which are not schema based are also by default supported here. So if you go through this, all these formats are also supported. And what are the advantages to work with protocol buffers? It is efficient because it is working with binary format and text based data. Cross language support, it supports various types of languages. And strong data type is there. Data types are strictly to be followed whenever we are trying to define. Backward and forward compatibility from a language to protocol, protocol buffer to language. Without affecting the data structures and the meaning of the data structures, we can go for compatibility. And efficient network usage, because it is trying to define the messages in binary format. Transferring the data will take less bandwidth, so network efficiency. And it can also work with environments wherein you are working in mobile networks as well as IoT environments. And quickly look at what is Apache Thrift. It is a software framework which provides very clear set of abstractions, so the user need not worry about the implementation issues. It provides clear abstractions for data transporting, serialization and application level processing. So try to see. Thrift supports a number of protocols. These are the protocols supported by Thrift. And what are the advantages of working with Thrift? Just go through them. So whenever we are working with protocol buffers and Thrift, working with Parquet files becomes easy because they are trying to help us to have a cross language platforms, conversion platforms. So simply you give the protocol buffer file to the proto compiler, it automatically converts it into your specific language. So source code generation becomes much easy for us. So with this, I conclude about protocol buffers and thrifts and writing and reading into Parquet files. Thank you.